Hello and welcome. Let's do a fun little math problem that, to be honest, is not very practical, but will require a bit of lateral thinking, and it will be good practice on how to apply Pythagoras Theorem. And the question we have here is a rectangular glass sheet whose dimensions are x and y rests horizontally in a hemispherical bowl. The height of the center of the sheet above the lowest point of the bowl is z. Find the radius of the bowl in terms of x, y, and z. Well, here's a picture of our problem pictorially, and I'm going to add a couple more elements to it. I'm going to label this center point of the hemisphere, the origin, O, and I'm going to note that from the origin to any point on the surface of the bowl, the distance is going to be simply the radius. So from the origin to a point where the glass touches the bowl is also going to be the radius. And now before I tackle this problem, let's review the Pythagoras theorem. For any right-angled triangle with side A and B and hypotenuse C, and it must be a right-angled triangle, the relationship between the three sides is simply c squared is equal to a squared plus b squared. Alright, now that we've reviewed Pythagoras theorem, let's have a look at this problem from the top. Alright, so a top-down view of our bowl will simply look like a circle enclosing a rectangle, and our rectangle will have a length of x and a width of y. Well, another length that will help us most in answering the question is the diagonal length of the rectangle, which I'm going to label d. So let's find an expression for d. Well, from Pythagoras theorem, the relationship between dx and y is simply d squared is equal to x squared plus y squared. As we have a right-angled triangle bounded by dx and y, so therefore d is equal to the square root of x squared plus y squared. Now that we've found our expression for the diagonal length, let's look at this problem along the cross-section of the diagonal. So the cross-section along the diagonal of the glass would look like this. We have a half circle with the origin in the middle. The height from the glass to the bottom of the bowl is z. So the distance from the origin to the glass is the radius minus z, and the distance from the origin to one of the contact points is the radius. And finally, this distance here from contact point to halfway is a half of d. So we now have a right-angled triangle that we can write in terms of r, the radius, and z, and d. Well, 1/2 of d will equal 1/2 of the square root of x squared plus y squared, because d we found to be equal to the square root of x squared plus y squared. So now we have the right-angled triangle expressed in terms of the radius, z, and x and y. So from Pythagoras theorem, we know that the hypotenuse, which is our radius, is going to be equal to well, the square of the radius is going to be equal to the sum of the squares of the two shorter sides. So it's going to be equal to r minus z in brackets squared plus 1/2 of the square root of x squared plus y squared all squared. So now it's a matter of using our algebra skills and expanding these brackets. The first one is just a binomial expansion, and it's going to result in r squared minus 2rz plus z squared. And squaring the n term will give me 1/4 times x squared plus y squared, as I've simply expanded this square into the brackets according to my index laws. So r squared is equal to r squared minus 2rz plus z squared plus 1/4 times the sum of x squared plus y squared. Now, since we've got r squared on both sides of the equation, we can actually cancel them out. And that will leave us with 0 equals minus 2rz plus z squared plus 1/4 times the sum of x squared plus y squared. Alright, so what I'm going to do now is to add the term 2rz to both sides of the equation. So that will give me a 2rz on the left hand side. It's going to eliminate the negative 2rz on the right hand side, leaving me with z squared plus 1/4 x squared plus y squared. And now I'm going to divide both sides of the equation by 2 times z. So that's going to leave me with just r, the radius, on the left hand side, and it's going to leave me with z squared plus 1/4 times x squared plus y squared all over 2z. I'm going to slightly beautify this equation a little bit by multiplying the top and bottom by 4. So that will so effectively I'm going to do this, multiply the top and bottom by 4. So that will leave me with r is equal to 4z squared plus x squared plus y squared divided by 8z. Let me write the 8z a little bit more neatly. So there we have it. We have successfully found the radius of the bowl in terms of the variables x, y, and z, which is what we were asked to do in the first place. So I hope this video has better helped you understand how to apply Pythagoras Theorem. Please give me a thumbs up if you have found this useful. If you are a math student, please feel free to subscribe for future videos that may help you on assignments or exams. If you have any question that you would like me to do a video on, please feel free to comment on any of the videos that you've seen. Thanks for watching, and I hope you learned something.